Hey guys, greeting from team 1050. We choose the topic A, Kangaroo mother care. First, we need to give you some introduction. We want to develop a mathematical model that captures the dynamic of mother-infant interaction under KMC treatment. And we want to evaluate the importance of direct care, particularly KMC, for infant kangaroos and human infants during their first 28 days of life. Before stepping into the model, there are some important assumptions we need to observe. The first assumption is that health is measured by the quantity H defined between 0 and 1. And the second one is the total time of the model is 28 days. And the third one is KMC is applied to premature infants with a natural deterioration rate of their health. So let's look at our basic model. You can check this model. We can say the rate of change of health equal to KMC effects minus natural deterioration rate plus external factor. And now we can see the math notation of our model. Firstly, the KMC effect we denote it as capital KT. It is influenced by skin-to-skin contact time S, and the interruption time I, and the quantity of KMC care Q, and some special factor C. Secondly, natural deterioration rate is defined as D. Since KMC is treatment general for the premature infant, we suggest the infant's age will decrease. Lastly, the external factor ET, we consider it as a constant alpha, which can be either positive or negative based on the factors such as environmental factors or financial factors.
Let's get a closer look at KT, which is influenced by ST, IT, QT, and the special factor C. So for ST, it's based on the paper and data in National Library of Medicine. The effect of the skin-to-skin contact will appear diminishing marginal effects over the hours greater than 8, and thus we use a logarithmic function to model such effects, represented as function 2. Based on our scale of the health age, the value should not be greater than 1. Thus, we did a normalization to ensure appropriate ST. The graph indicates the overall trend of the ST. The initial few hours of KMC will bring tremendous positive effect on KT's positive effects. However, after 8 hours of the increasing rate of effect will begin to decrease and approach to a constant value in the end. As for IT, it measures the interruption of days that occur during the overall KMC treatments. According to data from National Library of Medicine, the miss of few hours KMC treatment will not tremendously sabotage the overall positive effects. However, there is no specific data about the exact hours. Thus, according to our own model fitness, we suspect such effect have a high probability to occur around the 3 to 5 days of interruption. We model this situation by function 3. The model shows the initial 1 or 2 days of interruption will not severely influence the KT. However, when t is greater than 3, quality of KMC QT will be negatively influenced with an increasing rate. The graph suggests that to minimize the negative impact of interruptions on infant health, especially for those with a more extended sensitivity period, which is represented by higher B values, consistent care is essential throughout the first half of the 28-day period.
So next part is about the quality QT of the KMC. The QT measures the quality of KMC for each day. For QT, we reasonably model it. It will be influenced by two factors, Q base and Q experience. The base represents the theatrical knowledge that the parents can learn from the medical doctor. This value can vary based on the learning ability of parents, which is measured on their educational background. According to the data, we suggest that this parameter can vary from 0.6 to 0.9. Experience indicates that this hand-on experience for the KMC treatment. We all know that the theory is not everything, right? The experience is modeled by a factor Q increment, which is a constant times a ratio T over the capital T, which is just a total time equals to 28 for this case. This factor suggests that the KMC treatment operator will gain more and more experience day by day, causing a better treatment next time. So we model it as the equation 4. The graph suggests that even with different knowledge base, but the overall quality of Q will be better and better. And for some special factor C, it indicates a situation that some infants that are not suitable for KMC. Some infants may be born with special dermatosis, which indicates that the skin-to-skin contact will even exacerbate their health issue. Thus, we measure it as a piecewise function. So if it's a special case, the C just be -2, and otherwise it would just be 0. Thus, the overall result of KMC-related part of the model is as the equation 5 said. And if we plug in the function that we use and some parameter that we use, we can see the KT becomes equation 6. So the next part, I'm going to introduce a natural deterioration rate, which is DT. The natural deterioration rate is based on the data from the National Library of Medicine about the premature infants with a mortality rate as 1.8%. So according to the data, we can also see that with over 63% of the total deaths happens in the first 3 days. So basically, it's a model that happens faster in the first part in the first 3 days. Otherwise, in other times, it'll get lower and lower. So we measured it as the equation 7. So for the external factor, which we said is a constant, we consider it as alpha. Based on our model, we choose it either as -0.1 or +0.1. It means that if the environmental factor and the financial factor can either support the infant's health or do the otherwise. So for the HT results, we can see that if we put in the final result, the overall health edge is shown to be improving over the 28 days period. The model does not show any decline in the health status if we just apply this model in our database. And the model seems to support the hypothesis that the continuous care part, especially in the early days, is very crucial for the infant's health. So however, if for the special case, this is going to be some very different because some people just not good for KMC. So if we apply more and more KMC treatment to them, so their health may even decrease, so which may make their health issue deteriorate. So for all the limitations of our model, we only have very limited data to determine the tuning parameters because so for KMC, most of the data just shows to just compare it with the regular or conventional cares for the premature infants, which is not usable for our case. So if we have the second limitation is that if we have better measurement for C with exact functions, that will definitely improve our accuracy of the model. But this also requires very professional medical knowledge and data because some genetic related issue can be very difficult for us to measure. The last limitation is that there could be better measurement for external factor alpha because we just use some factors as a constant to measure the temperature or light, something like that, their effect for the KMC. But if we measure it as a function, I can say that it'll be better. So these are the reference that we use. Mostly is from the National Library of the Medicine. So that will be all of our presentation. Thanks for listening.